here to talk about JavaScript automation. So looking at JavaScript with Selenium and Cucumber as well. Okay, so we'll spend up to an hour maybe talking about this kind of powerful combination. All right, so I'm going to be driving this today with the use of Testal Spark. Okay, so full disclosure, we have a pro trial, a fully featured pro trial that's available for 90 days, completely free of charge. But we also support a completely free version of Testal Spark that's going to be perfectly acceptable for you if you're just getting started with your automation and you want to take those first steps. Okay, so I'm going to be driving tonight's webinar using this tooling. We did a previous webinar on the use of Ruby with Selenium and Cucumber, so I guess this is part 2. All right, so let's have a look at what we're going to be talking about. So with Test-Evolve, we'll show you how straightforward it is to open a project and get that initial framework set up. So it's really going to take care of everything for you. All right, so nothing really for you to worry about there, but we'll take you through the layers of configuration and features that are available to you. All right, we are coming at this from a Cucumber perspective, so the use of BDD to capture your functional requirements. All right, so good practice BDD ordinarily says that, of course, we have a conversational aspect, right? So we have the 3 amigos, or the power of 3. So we have developers and testers and business analysts or product owners working together to define a piece of functionality that's going to be delivered, or in this case, something for which we're going to provide an automated acceptance test. All right, so we use BDD and we use Cucumber to run these BDD scenarios as automated tests. So because of that, we need to understand about the structure. All right, so we'll look at the use of features, scenarios. We look at scenario outlines when we want to parameterize or data drive our tests for iterative testing. Okay. Now all of that sits within what we would call the business layer of the automation framework. Okay, so the use of features and BDD scenarios, which makes that functionality or that test very accessible, very readable to an outside audience. Okay. The middle layer of the framework is where we see the step definitions. So this is where we take one of these scenarios and we start to implement the necessary code to turn that into a runnable automated test. All right, and then we'll touch on the page object model in just a second. But also we have useful features within Cucumber like background steps, which is going to give us the ability to run a common process or workflow on a web application, for example, that you would want to be at the start of every single scenario in that feature. Okay, and then with our scenario outlines, we'll look at the use of example tables to supply differing sets of data to have that test repeat over and over for a common scenario, but with differing sets of data. Okay, so we'll look at scenario outlines with tables to do that. Within Testal Flair. Okay, so that's our cross-platform studio application. We have a test recorder, a web app test recorder, or a low-code accelerator, as we refer to it. So we'll look at how that can be used to very quickly get you from a place of no code to some code, some initial code. So you have the makings of an automated test within a matter of seconds. Okay, but then we're going to dive deeper into the coding side, start refactoring some of this, actually using and implementing what's called the page object model. Okay, so this is going to give our code real structure, nice reusability between team members on a shared team, for example. It's also the kind of thing that's going to give us very low maintenance overheads in terms of keeping our code clean, not repeating ourselves, and ultimately giving the best kind of best practice coding standards that you can implement within an automation project. As we said, right, no test is actually a test unless you've got some verifications, some assertions, or some checkpoints within that. So we'll look at how we do that within JavaScript. We'll look at some helper methods where if something's failing, we want to add a certain amount of tolerance to allow that to retry a couple of times before ultimately we say no, that's failed, and that test is has now failed itself. So we'll look at those, and then just to look at your how you can actually reuse your functional test automation for added value, right? So we have the ability to add accessibility checks and Lighthouse audits, for example, as well as visual testing checks, for example, to these tests that you've just created, right? So you've just built a functional automated test. How can you now start to get maximum reuse from that test for different types of testing in different verticals for your web application? Okay, so all about adding value, or assessing quality from different perspectives, and you as a tester within your testing team adding value to that delivery. Talking about all different aspects of quality for your application. Okay, and then finally, with again with the use of BDD features and scenarios, and with the Test Evolve Halo real-time reporting platform, you have incredibly granular test level reporting, real-time reporting up to the second reporting. When you're running tests, it's going to push data whilst those tests are running, so you're not going to have to wait 2 or 3 hours for that build to complete. You're going to see immediate test results. But what you're going to get there is fantastic traceability back to your BDD scenarios, to your features, in a way that you can present to your stakeholders. So everyone is very, very clear on the latest build of code to a particular environment and what that quality picture looks like at the moment as those tests are running. All right, so we're going to cover all that. It's quite a lot to get through in an hour, so we best get started. The kind of the 3 main components of what we're talking about today. So underlying language, JavaScript. Yep, as I say, we do have a Ruby alternative and a Python beta version, but the focus today is on JavaScript. We're very much looking at Cucumber, as we said, and our driver of choice for this is WebDriver.js in this case. So let's just look at those in turn. Now, I'm no expert in JavaScript, that's for sure, and my honest opinion is that a primary choice for many testers choosing JavaScript, or even TypeScript as well, but JavaScript in this instance, as their underlying automation language of choice, can quite often be developer-led, I think it's fair to say. So we've got obviously some front-end developers on the team. I think there's often the theory that testers may well, on occasion, need some support from the development team. The front-end developers, and JavaScript, of course, is going to be more often than not that language of choice. So there's a synergy there to working in the same front-end language as your developers. Okay, so aside from that though, so what is it? Well, yes, it's very versatile. It's how modern web apps are written these days, of course, right? So it can be used for front-end, back-end development. Of course, it's supported by all of the main web browsers. It's a scripting language. We're actually using Node.js within Test Evolve Spark in terms of what we're doing today, all right? It's a server-side language, so it does facilitate end-to-end testing on both the front and the back end as well. So very flexible in that regard. A ton of libraries that you can make use of as far as your kind of extending your test automation frameworks. Purely on the testing side, frameworks like Mocha, like Jasmine, like Jest. Jest, we use Jest for unit testing, for example. And then and WebDriver.js, of course. So that's another JavaScript library. It will give you support for asynchronous programming, of course, for understanding the state of your web application under test. And in terms of picking it up, so maybe not the easiest for sure. It's probably in the middle ground, the middle side of that, the middle part of the scale, if you like, for new testers. Okay, so 0 to hero, I'm really here talking to testers primarily. Of course, this is a framework, as we say, that developers can and will work with as well. But primarily, I'm here today talking to you as manual testers looking to take first steps into automation. Or maybe you've got some Java Selenium experience, or maybe you've already tried some Ruby, you've tried that, but you want to look at the JavaScript side now. So in my humble opinion, it's not as easy, as straightforward to pick up as Ruby or Python is, but maybe it's after that, and maybe it's kind of a little easier than Java, for example, or C#, but somewhere in the middle. But again, of course, if you've got that support with your developers, then maybe that's less of a bridge for you guys to overcome. And of course, you know, a huge community as well out there on the internet. So, you know, you're not going to struggle to answer a particular question that you may have that specifically pertains to JavaScript. As regards Cucumber, so we use Cucumber simply as a means, as a runner, effectively, as a test runner, but it's the thing that takes a BDD scenario and effectively makes it a runnable, executable acceptance test. All right, so that's the part that Cucumber plays. You're going to see a load of discussion, quite rightly, on the internet, on the web, in forums, on LinkedIn pages, on Facebook pages, about the fact that people miss the point of what BDD is really about. So yes, I wholeheartedly agree. BDD is first and foremost about, it's a conversational, it's a discussion between, you'll hear the three amigos, the power of three, all right? It's a conversation between developers, testers, product owners, or business analysts about what it is we're actually building, all right? BDD, behavior-driven development. So it's right at the front of the process on a greenfield development, okay? We're building new functionality. It's the conversation, the discussion, the fleshing out of arguments, the asking of what if this happens, what if that happens, you know, trying to identify edge cases. BDD is the conversation that generates the features and scenarios. But of course, you know, a large offshoot benefit of that then is the ability to take those features and scenarios and make them into automated tests, right? And the reason we're making those automated tests is to show acceptance test coverage for that BDD feature, that scenario that you've just been discussing and you're just developing and you're implementing, all right? It's also very powerful to kind of reverse engineer and to use BDD scenarios to document the behavior of a current application that has maybe been poorly tested up until now. All right, so it does mean obviously we can make reuse of steps within scenarios in other scenarios. We can very easily data drive our tests by parameterizing using cucumber tables, example tables. But what we love is it gives you absolute transparency of your testing output, but also back to your source requirements, and that's so important in terms of getting buy-in from the business, giving them peace of mind, getting confidence from your stakeholders. And WebDriver, of course, you know, it's been around a long time. Huge community support. You know, peaks and troughs in popularity. There are other drivers, of course. We can think about Playwright, Puppeteer, WebDriver, IO, Nightwatch, Cypress. You know, there's a ton of them out there. You know, WebDriver still, I think, remains the number one open source. It is the only officially supported driver by the major browsers as part of the W3C standard. We see bindings for multiple languages. So we talked about Ruby, there's Python, we're here talking about JavaScript. And that's the thing that's going to allow you to test locally on your Chrome, Firefox, Safari, and Edge. Okay, so some of the things, some of the perceptions of years gone by that people weren't so keen on with WebDriver are, you know, quickly being removed, you know, with the advent of Selenium 4 and the ability to support you know, Chrome DevTools and stuff like this, the perceived flakiness. You know, there are ways of writing tests in a robust manner that mean these don't have to be problems. Okay, so yeah, that's what we're here to discuss today. So let's just look at the setup process required from a JavaScript perspective, just to get you up and running. So you can come to testevolve.github.io. This is our support documentation. Probably just come straight to the quick start guide. It's going to tell you about the component parts of Testevolve, Spark, Flair, and Halo. What we're here to do really is just look at the install side. So either for Ruby and for Node, if I'm looking at Node, I can click through here. It's going to take me to a page purely about the Node install. All right, so we support the current LTS version. That's what we recommend people use. So follow this link through here, and it's going to take you to the nodejs.org page. Okay, and there it's going to tell you what the latest LTS version is, 20.9.0 in that case. And then you can download that, obviously complete the install process. It will install npm for you as well, so that's Node Package Manager. if I just run a terminal session, if I just installed that, I can then go node -v. I can check my node version. I can do npm -v and check my npm version. All right, so that will be successfully installed. Okay, once you've done that, jump across to testevolve.io/signup. You're just going to register here as an organization with yourself as your email address as the administrator for your organization. And then you're going to be able to download Flair. Okay, so Flair is what we're going to use to very quickly create a JavaScript Cucumber WebDriver automation project. All right, so just register yourselves here. You'll get a token in your inbox. Set yourselves up. Once you've then signed in, you can come to the download section within the main menu over here on the top right. And it's going to take you to this page where you can download Flair for either Windows, Linux, or Mac. You can also, if you want, come to the resources and the downloads page on our .com website. Exactly the same download facilities available to you there. All right, so download Flair, and then we'll now look at how you use Flair to actually set that first project up. So following the download, I've opened up Flair, Testal Flair, our studio application. So you just sign in with the same credentials that you registered. Okay, so we start with our organization ID and your admin email address and your password. And then we log in. Okay, cool. Now it's going to give you options to either open an existing project, which you won't have yet, of course, or to create a project. So here's where we're going to focus. So we'll call this 0 to Hero JS. We're creating a JavaScript project. I come here, I'm just going to select my directory where I want to create that project. I'm going to select JavaScript and create. So this is where Flair is going to do everything it needs to do to kind of unpack you a new JavaScript Cucumber Selenium WebDriver project. All right, so it's going to check your version of Node. It's going to create the project. It's just going to then look at the packages that are required. It's going to install any Node packages, Node modules that you need, and then we'll open up the project. Now what it's going to come with as well is some example demo tests contained within. So once your project is created, you'll see that open within Flair itself. We'll look at it in the IDE, of course, as well. And you'll see these example tests that we can run immediately, start to understand a little bit about the structure of the code. Okay. Right, so as soon as the project's opened, it's going to come to a home screen. And we're immediately referencing our BDD here. Okay, so on the left we have reference to a feature, so a demonstration of framework feature, and then we have scenarios contained within. All right, so these are our BDD scenarios. We have two demo tests. One is designed to pass and one is designed to fail. Okay, now the easiest way to run those immediately is to click through to next. We'll choose this as a functional test. It requires a browser. It's locally on my machine. It's a desktop. I'm going to choose Firefox. That's really all I need to do. I click on next. We'll talk about reports later on, but for now I click on run. We see the console, and now it's going to spin up my Firefox browser, and it's going to run the two example tests that come with a brand new project that's just been opened for you. Okay, so there we go. It's just some basic login and login failure tests. We can see there one has passed, one has failed. All right, so that's really the process to unpack a brand new project. That's all you need to do. Now this is going to make more sense when we look at this in the IDE. So we recommend maybe something like Visual Studio Code for your JavaScript coding. If I open this project now that we've just created, there it is, 0 to Hero JS. So we can start to see the insides of it, what it's actually building for us. Let's take a bit of a tour through a brand new JavaScript Selenium Cucumber project. Okay, so we created this through Flair. Again, it's done everything it needs to do for you. Let's expand a few folders here. So we have a default configuration folder. We'll step through each of those shortly. We have an environments folder. We have a features folder. The features folder is going to contain the example tests, and as you author, as you write tests yourselves, they will sit within this features folder. So we'll dig into that in a second. And then we have some local results reporting folders as well. Okay. The other thing of note is probably this package JSON file here. So we have a couple of inbuilt scripts that we use. So just to run the first test from the terminal. In fact, if I do that now, I'll just show you how that works. Let's create a new terminal here. I'm just going to run from the root directory within the project, npm run test. And that's just the command line option to do exactly what I did through Flair. Run the existing tests, the example tests within the framework. It's going to use the internal configuration, it's going to use Firefox, and it's going to run those same two tests. Okay, so that's how we run from Flair, but also from the IDE itself. Okay, so just to note there, one of those tests is designed to pass, one is designed to fail. Okay, just to show you the difference in terms of what we actually see by way of output. Just on that note, if I quickly come across to the results folder here, I actually ran the tests twice, once through Flair, once through command line. I straight away I get an HTML report, so I can look at that in the browser. Let's do open with. We'll come back to that. Let's have a look. Building Finder. There we go. Let's do it like this instead. There we go. So open with. There we go. So I can look at the first report. So that's the an included report within the framework. I have one passed, one failed test. I can expand upon that just to see exactly where that has failed. Okay. So just stepping back to Visual Studio Code. The package JSON, as we're saying there, that's going to give you the scripts that you can immediately use to run your tests from the command line. We'll expand on that in due course, but let's just look at the test quickly. So the tests sit within the features folder, as we said. Okay, so we have a demo feature here. So this is a BDD feature. Right, my feature is to demonstrate the Spark automation framework with two tests, as we said, two scenarios. So a scenario is equates to a test in this respect. Okay, so the relationship between features to scenarios in BDD terms. So a feature can have one or many scenarios. So we'll look at recording and writing new scenarios shortly. But in BDD terms, we advocate nice, short, punchy, given, when, then scenario steps. Okay. Now this webinar is not nearly long enough to talk about all of the the theory and the best practice behind BDD, but safe to say from our point of view and really from the community's point of view, you want to try and keep a BDD scenario short and concise, very readable. This is the business facing layer of the framework, the top layer if you like. So anyone in the organization or anyone connected with delivery should be able to look at a scenario and understand what's being built and how we would expect to test that. Okay, so we have short scenarios with 3 steps ideally. A given step is always the starting or the entry point to a test. The when step are your definitive user actions that are driving the test, if you like, and the then step is typically an assertion. So that can be a positive or a negative assertion, looking for the presence of something, a certain condition, or asserting against the absence of something. But it's that process of arrange and act and assert. It's that same kind of model that you apply to your unit testing. Okay, so yeah, very short, very readable. And what we definitely don't do as well, we don't make specific reference to elements of the user interface within a BDD scenario. Okay, it should describe a flow within the application, but it should never really refer to clicking on buttons or selecting values from drop-down lists. In an e-commerce world, for example, it should talk about going to a website, searching for a product, and then completing a checkout. That type of scenario. All right, so in the features folder, you'll find this example feature. So I've shown you how you can kind of run those immediately. The point of having them there, of course, is that you can start to understand a little bit about the structure. So underneath the features file, moving to the middle layer of the framework is what we refer to as the step definition layer. All right, so this is where we start to turn a BDD scenario into an automated test with this mapping to a step definition. All right, so you'll see across our two scenarios, we had a common given step, a common when step, and then we had two different then steps, or two different assertions, if you like. This was the first one, this was the second one. So in total, we have 4 necessary step definitions. Okay, now again, we're going to explore these more when we actually start to write some code, but just to walk you through the demo code that you have in the project when you first start. All right, so we have a common given step, and really what that's doing is going or opening a new URL, the first page of the application. In our case, it was the login page to Testal Flair Halo. Our when step, this is where we're driving the test. We're doing, undertaking some definite user actions. So all we were doing there in this example test was entering a bad username, entering a bad password, and we were then clicking on the submit button within that form. Okay, and then, as we said, the two scenarios, they each had a different assertion. One was designed to pass the test, so it was a correct assertion, looking for something that would definitely be there. And one of these, an incorrect error message assertion, was looking for the wrong error message. And because, of course, that error message isn't there, this is forcing the test to fail. So you get to see a pass and a failure. Okay, so this is a step definition. This example test is already built with reference to the page object model. Okay, so I'll explain that briefly, and then we'll show how we implement that when we're writing code of our own for the first time. So really, the page object model simply says that for the page within the application under test that we are interested in, we have a representative page in our automation project. Okay, so everything we were doing in those two tests was on the login page of our web application. Okay, so we are going to start to identify and declare individual elements on that page within this equivalent page in our project. And any particular methods, things that you can only undertake as a user on that page in the web application under test, we will represent those workflows as methods or functions within our project as well. So you can see here, we build our own login page to represent that page from the application. And then there are a couple of things I was doing. I was entering a username, so that's a small method just designed to interact with one field and set some text. In exactly the same basis, I'm entering a password, so that has its own method, and I'm passing a value, an argument here. Don't worry, be happy is my password, so I'm passing that argument to this method on this page class. Okay, so what you end up when you use this page object model, of course, is very low code maintenance, which we'll dig into in more detail. But I think at this level within the step definition, you end up with very readable step definitions. Okay, so this almost reads like a manual testing script at that point. So our when step, when we enter our credentials, is made up of 3 individual steps. And if you just read through these one by one, yeah, it reads like a manual testing script. So enter your username, with that value, enter your password with that value, and then click on the submit button. So the page object model also gives you this nice, very readable step definition or middle layer of the framework. Okay, so now if I dig a little bit deeper, so we go to the lowest level of the framework. If I go into our page class, so this is our login .page. All right, and there's two things I'm doing on here. I'm using it to declare and identify individual elements. So this is the identifier for my username field. This is the identifier for my password field, for my submit button, and also my error message that is going to pop up. And again, we'll get into kind of specifics on the options that you have there. But in the two bottom values, or two bottom elements, I should say, I'm using a CSS identifier. So I'm using a data test attribute for the submit button, and I'm using a class for the error message. And then up here, I'm directly referring to the username or the password. Okay, as I say, we'll come back to that. Here we have what we start to see now is the methods within this page class. All right, so I refer to the fact that we had an enter username method. This is declared and is set to receive an argument, and what it's doing under the hood is referring to one of our page object elements that we declared up here. All right, so we can see here it's looking for the username input, which is declared up here, and then it is passing through the value that we passed to this enter username method, and we are sending keys, we are entering via keystroke that username. Okay, and then we do exactly the same thing for the password. So this is our enter password method. We refer to our password input field, which is declared up here. We give it a value, and then we enter that value within that input field. Okay, so those are typically your text entry type of actions within a dedicated method for doing that. And then we also have a simple button click. So in this case, I've entered my username, my password. Now I'm just clicking submit. Okay, so we have a dedicated click submit method. As we're saying, you know, that resides on our login page class. That's the place where I do this login, of course. So what it is doing is awaiting my submit button again, which is declared up here. So it's awaiting for an element that can be identified with a CSS class attribute of this, and then it's simply, I'm calling .click on that page object. Okay, and the final thing we did was to verify an error message. So we have a common verify error message. We pass an argument, in essence, the error message that we expect to see. Obviously, we know that we passed a good value and a bad value in the two tests, which is why one passed and one failed. And then what we do, again, using reference to our error message element up here, we declare a new variable, so error MSG, error message, is equal to the text that it is able to retrieve from the error message when it's displayed in the web application. So the error pops up, it retrieves the text within the error message, and it is declared as error message here. And we simply say if the actual text that was seen within the on-screen error message is the same, both in terms of value and the type, so being a string, it's the same as the argument we passed through, then we just return true. If it's not, then we're going to throw a new error, and this is the text that will be output. Okay, so when I ran that test earlier, one passed, one failed. So the one that failed here is outputting this error message that we've just referred to on line 31. Okay, submit error was not present when it should be. So this is the lowest level. This is the third layer of the framework. We started with features and scenarios, the business facing layer. We moved to the middle layer, the step definition framework, which, as we saw, we had common given and when steps for our two scenarios. And then we had two different then step definitions for the two scenarios. But each of those was referring to this page object model that we've just taken a look through. All right, so all of those were waiting for something on the login page, and we had an open method to go to the site. We had an enter username, enter password, and click submit methods. We just looked at those, and then we had verify error methods. So this, in its simplest format, is an implementation of the page object model. Okay, and then we just walked through, how some of these elements are actually defined up here, and then how we refer to them within our methods that we see here, okay, on the same page class. All right, this is all just contained in one page class that represents one page in the application. All right, so that's a brief walkthrough of the included example, or the demo tests, if you like. The other things at this stage to be mindful of. So you will see a default config folder here. Okay. And there are a number of YAML config files. All right, so one of the probably the two places to start. If you start in the config.yaml here, this is where you are going to specify an environment, and this is also where you are going to specify a type of test. So this could be a browser, or this could be a mobile app, or this could be API, for example. For now, for this webinar, we're just going to focus on browser-based tests. So that is our test type, and we have some login config there as well. So not much in that config file, but this is where it all starts. All right, so you're going to refer to your test type and your environment. So if you want to understand a bit more about environments, you specify local in this config file, and it is going to refer to anything that we have established here as a local environment. Okay, so you can create as many environments as you need to within this environments YAML. So you can have a staging environment, you can have a performance environment, you can have a UAT, a QA1, a QA2, or as we've got here, just local. So this is a free text entry file where you notionally create these environments. Now typically what we see is a reference to an environment name, of course, and then something like a URL or a site path to get to your application or example site. Okay, and we'll show you how we refer to those in due course. But that's the link between the config file and the environments, and how you select an environment and how you define an environment. Okay, so that's config. And now the next place where it's probably going to have most impact is your browser.yaml. Okay, this is how you are, for the most part, for a browser test, this is how you're choosing to run your test. Now, there's a lot of config on here. To start with, we are just going to focus on running browser tests locally. Okay, so that is driven from the first parameter here, which says either my source is local, I'm doing it on my machine, or I'm going to be using the browser stack integration, for example, which is something we have. So we're doing all of this as local. We have some timeout values here, but the first things to take note of are when you're working locally, you then come to a sub-level of configuration. Again, this is all opened and prepared for you, so you just make use of this now. So the first thing you're going to see there is a platform. So I'm doing this on a desktop on my laptop. It could be a mobile or it could be tablet, but this is desktop browser-based testing right now. Because I've selected desktop, then as you can see, I then have some parameters here that are going to kick in and take effect. So really the key one to focus on, of course, is your browser of choice for running that test. Now, when I did it through Flair, I selected Firefox, and what Flair is actually doing is overwriting any kind of default config that we already have here. But when I run it through the command line, it's going to refer to this default config folder, and in this case, the fact that I have Chrome set here. All right. So I've got maximize the browser set to true, which means I'm not resizing it. So this breakpoint width and height don't take any effect. If I'd selected mobile here instead of desktop, then this configuration down here would apply. If I had have selected browser stack up here instead of local, then this configuration down here would apply. All right, so Equally, we have Browser Stack, we have Cobaton, Source Lab, so we have different types of integrations as well. So it's beyond the scope of this webinar, but know that they are there and they are there for you to take advantage of. These are plug and play type of integrations, so you will need a license key, API key from one of those providers to use their surface, but if you have that, then this is where you configure your tests. Okay, and then just most recently, probably worth note, we've now introduced support for Chrome for testing, and also the equivalent service, if you like, within Firefox from Mozilla. What this means is that if I set this to default, it's going to use the current version of Chrome that I have on my system. Likewise with Firefox. I can specify some certain parameters, so I can specify stable, beta, dev, or canary for Chrome, and it is going to use the Chrome release channels to go and download that browser for me. So if I say stable, it'll go and get the latest stable version if it's not already on my system. If I specify beta or dev or canary, it's going to go download the appropriate beta, dev, or canary browser instances from the Chrome for testing site. Okay, so browser management and driver management is now completely taken care of within the framework for you, so you haven't got to worry about any of that. Similarly, I can also specify major versions, right? So I can say 119, 120, I think 119 or 120 are the latest kind of Chrome versions at the time of running this webinar. With Firefox, I believe the options are default for the current version of my system. I can specify stable, dev, beta, or nightly. So instead of canary for Chrome, we use nightly for Firefox. And that is going to give you up to the minute latest browsers, but of course be aware these browsers are still very much in development, right? So you've got to decide how and when you want to use these certain browser types. But I can also specify, again, version 115, 116 major versions. Okay, so those are really the main elements of configuration that you're going to need at this early stage. Okay. We do offer some other features. We'll look at Lighthouse and accessibility testing in due course, but there is some specific configuration for that, which we'll come back to. Mobile app testing is beyond the scope for this particular webinar, but we have configuration for local and browser stack based mobile app testing. And then when we're running some tests locally later, we'll look in more detail at some of the reporting configuration. But for now, the areas of focus would be the config.yaml to refer to the environment and the type of test, and the browser.yaml to make your browser-based choices. All right, so that's just a run through a brand new open project. Everything is built for you. The configuration is there. You can run these demo tests immediately out of the box, as you've seen. What we're going to move on to now is very quickly authoring a new request using the web test recorder. So now we've explored the example, the demo tests briefly. We've had a bit of a walkthrough. I just wanted to show you a feature that is available to you within Testal Flair that allows you to very quickly write some code for the first time. It's a web app recording tool. It's what we refer to as a code accelerator because we are a coded framework, and we fully expect as automation engineers and users of this framework that we will be kind of rolling up our sleeves, getting our hands dirty, diving into the code and doing some refactoring. But know that you have this tool at your disposal to very quickly generate new tests for the first time. All right, so if I come into the develop module over here, it's going to give me a view of the features and scenarios that it already sees in the project, but it's going to let me author some new BDD features and scenarios as well. So let's focus on an Amazon checkout flow, and I want to create a scenario. I'm just going to call it add product to cart, so I can create my feature, I create my scenario. This does it for me. And let's keep it real simple, nice, clean and concise, like we say. So given I go to the Amazon UK site, when I search for a product. So again, what I'm not doing is referring to any elements of the UI. Okay, this is all about the user flow, what I want to do with the application. Then I can add that product to my cart. And let's approve that. All right, so Flair's just very quickly and easily enabled me to create my feature, my scenario, and my given when then steps within that scenario. Again, so Flair is continuously interacting with, apologies for the typo there, is continuously interacting with the underlying code base on your system. Okay, so we'll see that in a second. But so from here, I can click on the given step. There is no code yet; it's undefined. I've just created the step itself, but no code. So let's click here to begin recording. The first thing you'll see here is a kind of page on our website. It's like a training page, effectively. So you can come here and either you can look at this manually on the website, so it's .com/element-capture. This page is loaded with different types of elements, links, buttons, input fields, phone number fields, password fields, radio buttons, checkboxes, etc., etc., that allow you to inspect and kind of test against, so you understand the type of code, either for a Ruby or for a JavaScript project, or soon to be a Python project as well, that will be generated for your page elements. So we make that the first page that loads when you look at the recorder here, because it can be a handy tool to kind of learn your way around and understand a little bit about the nature of these elements. Anyhow, back to my Amazon flow. So I click record. I'm going to go here. Let's go https amazon.co.uk. So my given step is going to the site. Well, this is the only thing I've got to do within the given step. So I can either enter there or I can click on this arrow and it's going to load the Amazon homepage. All right, so we can see straight away on the left-hand side, it's starting to generate my code for me and writing it kind of within my given step, if you like. So if I want to move into my when step, I then just expand that here and it will tell me again that this step is yet to be defined. Well, I just continue going at that point. So my when step is about searching for my product. So I click here. It's Christmas coming up soon, so I'm going to search for Christmas trees. I'm going to spell better than that to start with. There we go. And I'm going to click on the magnifying glass, and everything I'm doing is being captured and recorded on the left-hand side. So I think that probably satisfies my searching for a product step. So I'll tell you what we'll do. Let's just add an assertion there, because we can do this as we go along. So I want to assert now that I'm on the results page, for example. So I just right click there. We just have some very simple assertions that are available to you at the time of recording a test. Of course, you can do slightly more complex things when you're refactoring your tests, but for now you can quickly add a basic assertion there. And you can see that that's been written to my code as well. Verify displayed a particular element. That's my when step. I want to move on to the adding a product to cart. So then I can add that product to my cart. So I click into that step. Again, yet to be recorded, so that's fine. I just keep recording. I keep navigating around the app, doing what I want to do. So let's pick one that I like the look of. There we go. We'll go for classic, £16. So I can click on that guy. I'm taken to a product detail page at this stage. So maybe there's a few things I could assert here. So I could assert that I'm on this page by ensuring that there is a back to results link. So I could go there, verify that that's displayed. I could also, how else do I know that I'm on the product detail page? Well, by virtue of the fact I have an add to basket button, so I can assert that this is displayed on the page. And then actually all I really want to do is add that to basket, because that's my then step. So let's click on add to basket. And that's it. I'm going to stop recording at that point. But yeah, this is just a real quick way of getting to grips with creating feature files, creating scenarios within them, building out the given when then steps. When you start to record, that's going to generate your step definition layer as well at its simplest level. Okay, so let's just come across to VS Code now. Okay, this is the same project. This is where we started. All right, we now have an Amazon checkout flow.feature. So by doing that, it's built all of this for me. It's built my feature file. It's named my feature as I did in Flair. It's named my scenario and my given when then steps, spelling mistake and all to my feature file. Okay, so that's the top layer of the framework. It's done that for me. If I open my step definitions folder, it's also, when I started actually recording, interacting with the application, it started building out my the code for me. All right. So again, this works if you open a Ruby project, it will do it in Ruby. If you do JavaScript, as we have done here, it's going to do it in JavaScript for you. So Testal Flair is going to construct these files for you in the appropriate place. It's going to make all of the necessary import statements up here. And then what it's done for us, again, if you think back to our example tests, it's built me a given step, a when step, and a then step. All right, so just, again, I've not implemented the page object model yet. So what this is doing is recording my code statements at the step definition layer, if you like. Now, of course, we will dive in and we would refactor this and we would turn this into a page object model implementation. And we'll focus on that shortly. But it's worth knowing, again, you know, I've recorded this on the Amazon site. I could have gone through the trainer page on the testevolve.com site. But it's going to start to build the code out for you, right? So you see here that the launching of the application or going to the site is based upon an await testevolve.browser.get and then my URL, okay? So that's its instruction to open up the browser and go to that URL. Now, the first thing I did once that homepage loaded was to click into the Amazon search box. So that's represented there using the find element Selenium command. And the recorder has chosen to use that inputs or that text box's ID attribute. Okay, so find element by ID, and it's used its unique attribute there. So that input on the Amazon page. And you can manually inspect and see this for yourself on the Amazon page, but it is the 2-tab search text box is its ID. And the first thing I'm doing before I can submit text, I'm clicking into that. All right, and then so for the same element, I'm then submitting some text. So send keys, Christmas trees. That was my search. Now, when we look at the refactoring of this, the page object model, we will make Christmas trees an argument, for example. That would be something that we can pass through from a scenario outlines example tables, for example. So we'll come back to that. I then clicked on the magnifying glass. Okay, well, the recorder has chosen again to use an ID. So it's found the magnifying glass. It has a unique ID on the page of nav search submit button, and then I called dot click upon that. So, you know, this was just me navigating through and it's picking this up for me, writing my code within the appropriate step. Okay, and then if you remember, we because we then submitted our search term, we actually we raised a very simple assertion just to ensure that we had been taken to the results page. Okay, and the crux of that assertion is here. So we are looking for an element on the page that has a class of this, so a size medium plus a blah, 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 blah. Of course, we're making sure it's displayed. So that was the verification that we chose within Flair. But what we're saying is, by the fact we've got an exclamation mark here, we're saying if that element is not displayed, then throw a new error with this error message here. Okay. So in this instance, Flair has written your verification, your checkpoint, your assertion, whatever you want to call it, and it's added a predetermined error message there if that check is not successful. All right, so when we're refactoring these, you know, we'll look at, okay, maybe I would choose to give that a different name. you know, maybe I would choose to write a slightly less generic error message in here. Well, of course I would, but this is what the recorder is going to do for you to start with. It gives you the skeleton within which to work. Okay. And then we were adding that product to cart. Okay, so I picked a product essentially. All right, so I clicked on that product. When I was on the product, I added a couple of assertions. So the first thing I was looking at was, and you can kind of see it from the ID here, the breadcrumb backlink. So this was the link that was going to return us to the results page. So we use this as an indicator that we were definitely on the product details page by virtue of the fact that this link was present. Okay. Of course, it's not the only assertion that you would make. It's not the most complex assertion, but it's enough to get you started. All right. So same principle, exclamation mark. If that link is not present on the page, then throw a new error with the generic error message. Okay. And again, you can refactor and update these however you want them to, however you want that error to actually be thrown and the message that you receive in the console when it does fail. Okay, and then this one's reasonably obvious. We then did a check to ensure that the add to cart button was also displayed. Of course, that's a good indicator that we're on the correct page we expect to be. And then quite simply, that same element, the add to cart button, we clicked on that to add the product to cart. Okay. Now we could have gone on, we could have gone into the cart, we could have made additional assertions, but that wasn't the point. You know, the point here was just to show you how you can use a recorder to build the appropriate files within the project. So it started out by building the feature file. It wrote to that file, so it wrote my feature name, it wrote my scenario, it wrote my 3 steps. We then used Flair when we were recording, to create the step definition and to then start generate JavaScript code into the particular or the correct step, the given, the when, or the then step that requires that code to do what it needs to do. All right, so as I say, this isn't an implementation of the page object model when we've recorded this, so we don't have a pages file, so we just have the top 2 layers of the framework for now, the feature and the step definition layer. Okay, what we'll look at now is how we would take that kind of user journey on that kind of e-commerce website and how we would refactor it to respect the page object model, but we'll now start to look at how we can inject data through our scenarios, through the use of inline tables and examples, in order to kind of parameterize that test and run it multiple times with different data sets, to run it on a more iterative basis, or just to be able to pass arguments through our feature and our scenario layer to our underlying code, either to assert something or to submit a different entry in a particular field the next time we run the test. So we'll look at refactoring this code now to see what that would look like. So we talked about how we would now look at some refactored code, right? So we looked at how we can record a very quick and simple test with the recorder, but ultimately the recorder is an accelerator and it's designed to kind of get you up and running quickly, but with best practice coding standards in place, we're going to want to refactor this code, and that's what we're now going to look at. We're also going to explore some different scenario variations in terms of structure and how you can pass data through. All right, so let's just look at the first refactored version. Okay, so we're still concentrating on our Amazon checkout flow. This version here was the scenario that we recorded with Testal Flair. And this looks very similar, but now this is a refactored page object model based or implemented scenario. Okay, so the first thing you'll see is that the given step has disappeared. Well, that's because I've actually taken it up here and tucked it within a background step. All right, so this is something that Cucumber allows you to do within your feature. You can have something called a background step. You can put a description against that, and then you just place your whatever step it is that you want to run as a background step underneath that background. So the point of the background is that it will run that common step for every single scenario that follows it. All right, so it means I don't need to repeat the same given step over and over again in each of these scenarios. Okay, so as I start to come down here, of which I'll explain what these are in a second, I'm really just focusing on the things that are unique to this scenario. All right, the commonality is tucked up here. Okay, so what I've done, if we now step through into the checkout flow steps, And again, I've just marked up this this step definition file, so you know, we know kind of where we come from and where we're going to, right? So this given, this when step and this then step were the ones that we recorded directly from the browser. The code's written to our project here. What I've now done is refactored these steps. Okay, now this was what I just referred to as the background step. So that is simply a browser kind of get or go to command just to load that particular page. Okay, but once we then start to get into the when steps and the then steps, we're now making reference to this page object model. Okay, so what that means is that journey through the web application, I moved across 3 pages of the application. I hit the home page. I executed a search from there, which took me to the results listings page. From there, I selected a product that took me to the product details page. So, you know, essentially, I could have added a basket page or a cart at the end of that, but essentially it's 3 kind of major areas within the site. So for the sake of this, we've called it home page, results page, and product details page. Okay, so I've created these 3 new pages. Okay, and you start to see that this code is looking a lot cleaner now, you know, a lot kind of lower maintenance. Now, there's a couple of things I need to do. Firstly, when I create these pages, and again, you know, when you open a new project, you will have example pages in there for the example test that we already looked at. So I've copied the structure of that particular page. I've added it down here in this pages folder. All right, so we have a home page, we have a results page, and a product details page. Within each of those, we're kind of exporting that as a new class, so product details page. And in order for me to be able to reference these pages from the step definition file, there's a couple of things I need to do. I need to add them to this this index.js file here, which sits within the same pages directory. So each of those pages is referenced. This first one is from our example test that you get within the project. So I've since added the home page, the results page, and the product details page. And then within the actual step definition file itself at the top, I also need to then import those pages to my step definition file. Okay, so that's how we do that. You'll see these other things. These were added automatically by Flair when the project was created and when we started to record some code. Okay, so but these ones I've manually added when I built these pages 1, 2, and 3. All right, so that's just about the structure. Coming back to how we actually use these, so if we kind of refamiliarize ourselves, so there's our background step. So there you go. When I search my product, so it's based of 2 steps really. It's the actual search, and then it's the verify that we get some results that are returned. All right, that's really what searching for a product is involved. So that when step takes us across 2 of the pages on the application. So this is JavaScript, so I have to await almost everything. All right, it's the asynchronous nature of JavaScript. And I'm referring here to my homepage page class, which is here. And within that, I've got a method here, search for product, which will receive a value. All right, and there is the method, me calling it. So I'm searching for products. The thing that I'm searching for is Christmas trees. Okay, in this case, it's hard-coded within the when step, if you like, but we're going to talk about how to expand upon that shortly. Okay, and then I'm making reference to a second page, the results page, which is this guy here. And again, I've just got one method there, which is a verify results method. So that's going to say await the results page, verify results. All right, so those are the 2 steps that sit within my when step. All right, so let's just look a little deeper at those. Okay, so let's take the search for product on the home page. So there's 2 things that are going to go on within this page class. All right, so this page class represents this page within the application, as does the results page, as does the product details page, and it has 2 main purposes. It's going to allow me to better store my individual page element references. Okay, so what do we need for searching for a product? Well, we need the search input, we need the search button. I've added something as well, because what you'll often see when you hit the Amazon homepage, especially in a private browser window, you'll see a banner at the bottom, which is a clear cookies banner. So as part of my automation effort, if that's there, I want to clear that. So I created a separate element for this as well. Most of the time, I'm going to use CSS locators, okay, to actually identify these elements. So you'll remember that the recorder identified the search box and called it the 2-tab search text box. Well, I'm now declaring that as an element that I'm calling the search input. All right, so I'm using a CSS locator. It makes reference to the fact it's an ID, and that is that ID. All right, so that's the pattern we follow for these other page elements as well. So in my search for products, so the first thing I'm doing here, I am checking if that cookies banner is displayed. And if it is, I'm then clicking on the button to clear it. All right, again, I'm awaiting pretty much everything. So if await the cookies button is displayed, so if returns true, then await this cookies button dot click to clear it. Okay, so that's just a kind of conditional statement if it's there. Aside from that, either whether it's not there or it's clicked it to get rid of it, I'm doing three things now. So within my search for product method, I'm now able to reference these page elements here to create my method. Okay, so again, I'm awaiting. So search input dot click, search input, send the value that I've passed through. If you remember from the step definition, that was Christmas trees, and then search button dot click. All right, so that's the basis of how we use a page class to do two things: to identify the elements and then use them in a method that I'm going to need to action on that particular page. All right. If we look at it, what else we're doing on the results page, the next page along. So I've got one element and I've got one method that uses that one element. All right. So I've got something that I've called the results listings. Again, I've used a CSS locator. It was a class, and here is the thing that it's referring to. So this is the grid of results that you get when you complete a search in Amazon. Okay. And the method that makes use of that is called the verify results. And I have the ability to pass something to that. I'm passing through an error message if I wish. I'm not actually using that here because this is still hard-coded at this stage. But you see here, if, and this is really a negative assertion, so what I'm saying is, if my results listings, I'm asking if it's displayed, but I'm prefixing that with an exclamation mark, so I'm turning that into a negative. So if that results listings is not displayed, then throw this error here. So that's my basic assertion. So you can see that I'm calling that from here. Results page, verify results. So I could pass through a specific error message there if I wanted to, and I could refer to that error here if I wanted to use my own custom error message. All right, but in this case, I'm just using a general kind of hard-coded error. So that's what's going on the results page, and then on the product details page, we've got purely the add to basket method. So a little bit more going on here, right? Because we've got some assertion elements as well. So we've got 1, 2, 3, 4, 5 elements. So I've got something called my product. I'm looking for a return link, an add to cart button, a success message, and a proceed to checkout button. The majority, I usually choose to use a CSS locator, as we've already discussed. So you can see breadcrumb backlink, an ID of add to cart button. This is a slightly differently formatted one for a success message once I've added something to cart. And when I was then on the product details page and I added to cart, I then had the proceed to checkout button. So these were the identifiers for those. One difference here, I used an XPath locator strategy here, okay, based upon a text entry. So this was, it's quite long-winded, but I can do that with XPath, but this was the specific product from the search results that I was then clicking on and then adding to cart. All right, so my add to basket here is made up of a few things, right? So first of all, I'm on the product details page, so I find my product and I click on that product. Okay, so that takes me to the product details page itself. Okay, this is an assertion then to make sure that I find myself on the page I expect to be on, right? So if I can see a return to results listings link, then that's a reasonable indicator that I'm on the correct page and that, you know, the thing I expect to have happened, the fact that I'm on the product details page is actually the case. So an error message there, return link was not displayed. So same thing, it's kind of a negative check, so I'm just doing this as an await. This element is displayed, prefixing it with an exclamation mark to turn it into a negative check. So if it's not displayed, then throw this error. Okay, similar thing here. I'm on the same page. I'm also saying if the add to cart button is not displayed, throw an error. Once I've made those two checks, I'm then saying, right, great, add that product to cart. So I'm simply on the product details page, clicking on the add to cart button. So await this add to cart button dot click. Again, all the time it's using these elements up here that I've defined earlier. And then again, I've got a couple of assertions, a couple of verifications in the same format. I'm just checking that something's displayed. So once I've added it to cart, I want to see a success message to confirm that that's been that's the case. And if I've got something in my cart, I can then proceed to checkout. So again, using the checks in the same format, throwing an error if these two expected things, a success message and a proceed to checkout button, if either of those is not displayed, then I've got kind of individual error messages for each of those. So that's a kind of a full implementation of the page object model. All right, so if I come back to the feature, so this was our refactored ones here, so I can just quickly run that test. I'm going to just do npm run test minus tags at 1, so that's how I can run a specific test by the use of a tag here. So if I just run that, it's going to use the same default config that exists within the project. We'll let the browser spin up. There's the cookies banner, it's got rid of that. There's the search, there's the results listings page, there's the click, there's the product details page, making some assertions, adding to basket, making some assertions, and there you go, that test is now passed. All right, so that's kind of a deeper dive into the page object model. All right, so hopefully that's useful. What I wanted to take you through now is just some variations at the scenario level. All right, so we've got essentially the same code. So that was number 1 we just went through. We're looking at number 2 now. So the difference here is that this is a scenario outline. Okay, so it's still using the page object model, but it is a scenario outline. Now what that essentially means is we can run this test over and over and over. We can pass through additional products, and it's going to run an individual test for each of the products that we add to this list. Okay, so if I run number 2 very quickly, you'll see that it's essentially going to go through this test twice. It's going to search for Christmas trees the first time, and then it's going to go and look for balloons the second time. Now I've chosen in the config not to use the same browser, so it will open and close a browser both times. Here we go, second browser, now searching for balloons. There you go. All right, so in these kind of simpler examples, I'm not doing the add to cart stage. I just want to show you how you can structure your scenarios to achieve this type of throughput or iterative type of testing. Okay, so the thing is that's going to look different in the step definition. All right, so if you think what we're doing here, we are essentially we're making use of an examples table that has a header of product. So the first time it runs, it's going to pass through Christmas trees here as the product, and the second time it's going to pass through balloons as the product. All right, so if we look at the checkout steps and we look at how that code looks for scenarios 2 and 3, this is what it looks like. Okay, so we have a step definition that is kind of set up. It's using a regular expression here to extract whatever is being passed through, and then we refer to that as product. And rather than having Christmas trees hard-coded here, I pass through that value that was captured with the regular expression to my search for product method here. Right, and the fact that it had 2 lines in the examples table meant that that test itself would run 2 times. That's going to record 2 individual test results. All right, so it's a nice quick way of expanding, the use of a test. I mean, that could be a bunch of things. These could be different payment methods, they could be different addresses, they could be different products, whatever your test is doing. This is the way that you can pass through data to repeat it over and over with varying data sets. All right. Number 3 is simply passing the value directly within the step itself. So it just says when I search for the Christmas trees. All right. Well, that is achieved in exactly the same way. Okay, just by use of this regular expression here. That's capturing anything that's passed through after the word. So when I search for the whatever something, whether it's a table or whether it's an individual word or a string. Within here, as we can see, it's going to capture that, and that will be passed through as the value that is then passed on to the search for product method. Okay. Example 4 is something we call an inline table. So it's similar to a scenario outline, except it's only really using one value, but it just makes it what it allows me to do. Really, I could just take a copy of this entire test. I could duplicate that, and then I could have a second test that's looking for something else, bananas. All right, so that in effect, running these two back to back is kind of similar to having two examples in a scenario outline, as we saw up here. It's just a slightly different way of doing it. Okay, but well, let's look at how we do that. So here's my step here. When I search for a product I want, I just have this thing called an inline table underneath that. It still has a header, which is product, and then an actual value, which is Christmas trees. So if I look at that in the step definitions, so scenario number 4 is our inline table. So I've got my my step here. When I search for a product I want, and then I'm just passing through this value table here. Okay, but I have to. It's similar to passing through. In the way we did in the previous examples, but I have to refer to it differently. Okay, so for me to extract the value from that table, I've got a command here that says table.hashes, and I'm referring to the first item in that table, which is an index of 0, and I'm making reference to the header here, .product. Okay, so just as a reminder, here's my table. I'm taking the first value, or the first row, I should say. And whilst we've only got one column, that column is product. So I'm referring to the product column, or the value that is in the product column, from the first row here, index 0. So that then becomes my search term. Okay. And then finally, we have what we call a doc string. Okay, so just again another way of doing it. So all of these using our background step up here, if you remember to go to the Amazon website. Okay, so when I search for something I need, and then I can just have a doc string here. Okay, not something I personally use a lot. I tend to use example tables with scenario outlines. Even if you've got just one example in there are times when you kind of expand and contract the amount of iteration you want to do for a particular scenario. Okay, that's maybe one of the downsides to scenario outlines. It's very easy to maybe overstuff these with too many examples sometimes. You know, the only examples you really want in here are things that are going to add value to your testing. All right, so if there are critical products you have to search for, or you absolutely have to do a MasterCard payment and a Visa payment and a PayPal payment, then those are the kind of must-have values you'd want to use in an examples table. All right, but inline tables can be very useful because again, it's adding some clarity to the feature and the scenario for kind of a wider audience to understand the test coverage. Right, so if you had examples tables or you had inline tables here. Bearing in mind that this is all output to your test results, you're going to understand, you're going to be able to share your test coverage with your stakeholders, the people, people on the delivery team. Now this is great, right? When I search for a product, in terms of it being a nice, clean, concise BDD step, but it doesn't tell anyone, exactly what that product was, because actually it's tucked away within the step definition here. When we start to add some of this stuff to the feature and the scenarios, again, it makes it all that much more transparent. All right, so that was a kind of a bit of a deeper dive into a refactored Amazon checkout flow. So we recorded it initially, we refactored it into a 3-page based page object model implementation. And then we just had a quick look through some varying types of feature scenario outlines, different techniques for passing data through from the feature level to the step definition layer, and then ultimately down into the methods that exist on some of those page classes. All right, and we also explored the use of this background step as a common step for every single scenario that sits on here. All right, good stuff. And what we're going to talk about next is just understanding a little bit about how I could now extend these tests to look at a quick accessibility check, to look at a Lighthouse audit. And then ultimately, what the most important thing is, I'm running these tests, I've written them, I'm running them, I've got some product variation in there. I want to start outputting these results to an accessible place where people can start to understand how and what and why we're testing, what kind of coverage, and the success of those tests. So we'll look at how we publish real-time results now. Okay. Hey guys, moving on to reporting. So when you register, you're actually registering against a test evolve Halo. Okay, so it's our reporting platform. You create yourselves an evaluation account, you'll be an administrator, but this is where you start to push and see, analyze, digest your test results as well. So I mentioned the fact this is a real-time reporting platform. So what I did, as I've been executing these tests, I've been kind of pushing the data to this platform. Okay, so all that involves is me having an API key and giving a label to a test run. There's plenty of documentation on our GitHub pages and other YouTube videos that talk explicitly about this, so please do check that out. But let's start with a basic functional run. So with our Amazon checkout flow, I see here what we call a run card. We've got 3 different types here because I've run these tests in different ways, and I'll just show you that in a second. But the basic functional run will look like this. I can see that the test run is complete. That was done 16 minutes ago. I ran it locally on my machine. I ran it in a desktop viewport, as we've been seeing. My machine's a Mac, and I ran it on Chrome. Okay, so it's billed here as a functional test, as opposed to these two, which I'll explain shortly. So I can click into this and start to understand about my history of running these tests. Okay, so there are a few things on this page. Your latest run widget is in the top left-hand corner. It's your basic pass-fail metrics for the latest run, total scenarios, progress, pass progress, percentage, sorry, time for the run, average scenario, etc., etc. Down here you have a trend. I'll show you some more meaningful data in a minute that will kind of bring this to life a bit more. But you also have a duration there, average duration. I've not run this enough to actually have some data there, so we'll show you some in a second. Top right, you have your run properties. Again, so you learn a little bit more about how that test was run. So Chrome, OS version 14, Mac OS, run on desktop, as we say. We have a run history down here, so the number of times you've run these tests, so 20 minutes ago, 18 minutes ago. Each of them has a run ID. Again, you get some basic run properties, but you can click through your run history and you can see different views of data. This is essentially the same test run that's been executed multiple times. Just for a second, I'll click onto something that has a little bit more data in it. Okay, so if I look at a test run here with a lot more tests, 558 in this case. This is a real-time dashboard in the sense that if my tests, there's 500, 600 tests take an hour to run, or hour and a half, whatever it is. I don't have to wait for 90 minutes to get all the results. So each one of these things down here is a feature, like we've been looking at, a BDD feature. So, we mentioned it could have one or multiple scenarios within it. But as soon as you have a single test scenario result from a feature, it's going to be pushed to this results widget here. Okay, so you are continually receiving an updated set of results as more and more tests complete and pass and do their job. And the key thing here is that we elevate the failures immediately to the top. So Passing tests are absolutely fantastic. In fact, this one's just started to run whilst I'm recording this. So there you go. There you go. We can see all the real-time data coming through now. Okay, so every time we get a new result, it's going to populate like that. That was very, very timely. But yeah, the failures will go to the top. Okay, so let's just come back to the earlier version we were looking at. This is now an in-progress run, so it sits at the top of my history table, but we were previously looking at this one here. So as we see some failures, we can click in, all right, and then it's going to take us to the particular feature we just selected. We get obviously a red stripe telling us it's failed. We have the opportunity to raise a bug immediately. We have full traceability to our BDD features and scenarios. Partner create customers is our feature. Create customer organization is our scenario. Then here's our given, when, then steps. There's an and step here as well. We have a stack trace error, which helps us to start to diagnose. But we also have a browser screenshot here as well for that failure. So we can come in here, we see exactly where we were in the application at the point the test failed, helping us to diagnose very, very quickly. Once you've made that determination whether that's a bug or not, and that's something you want to raise with the delivery team, you can come here and use the Jira integration. You can click on Raise Bug. It will have access to the projects that you do via your API key, so you can just choose your project here. What's kind of nice is that it's already going to bring in the stack trace information for you, so you don't have to add that. So you just give it a summary description and fire that into your Jira instance. We will be adding the automatic upload of screenshots if they exist within the report to Jira in due course as well. So that's just briefly how the Halo dashboards work. Whilst that one is running, let's just come back and see some more real-time data. So this is now showing as in progress. It started 2 minutes ago. It's currently 97% passing. It's still running right now, but we can see that number of features has started to increase. There you go. The one failure that we see, there you go, real-time analysis. The one failure we see belongs to this set password feature. It's at the top of the pile, so it gets our attention. These are the tests that are yet to run. All right, so you can see in real time that these results are coming through. So I can, as soon as I see this failure, I can go in here and say, okay, what's the problem? There we go, there's my failure. And also, so we've used a retry here, so it's failed after 2 attempts. Okay, so we do offer the ability to retry a failed test. If it passes after a retry, we consider that to be a flaky test, and it will denote that here. But this is, there you go, real-time analysis. So I have a stack trace, I have a screenshot. I can start to decide. Straight away I can see here that what's happened is that for some reason the actual submission of this form has not taken place because the fields are still populated with data, but it hasn't made it through that click confirm stage. So I can and what am I, there you go, I'm expecting an error message. Well, that error message isn't going to happen because I didn't manage to click on that confirm button. So that's not a bug at this stage. That's something with the test that needs to look at. But this is how quickly you can start to analyze your failures. Okay, so coming away from that, the other 2 types of data. I mentioned how easy it is to add accessibility checks and Lighthouse audits. So I'm just going to come back to the code for 1 second and show you exactly what's been done. So we had our step definition file, and we had a homepage class and a search for product method there. Okay, so if I dig into the homepage class, I want to draw your attention to this. This is one single extra line of code that I've added within that search for product method. Okay, so by default it's going to be on the actually it's on the home page. I've listed that wrong. I've put results page. That should be home page, but this is a free text label I can give it. So I'm running an audit check. Now in Test Evolve terms, an audit is one of 2 things. It's either an accessibility check using our Axe core integration, or it's a Lighthouse audit. Okay, and that's going to be dependent upon your configuration. So one of the other files in the configuration is the audits.yaml. You'll see that up here. And all I've got to do is set auditing to be set to true. So it's gonna run that test as an audit test. And my source here is Lighthouse. I have a choice of Lighthouse or Axe. And that's what I was doing, okay? Again, we have other demos, webinars, tutorials that talk about the ins and outs of how you can use this, but I'll just give you a brief overview. So I ran the same test with this additional line of code here. So what it was doing here was clearing the cookies that it was always doing, as we've been looking at earlier today. And then before it ran the Amazon homepage search for product, it just runs an audit check. And in this case, I had my config set to Lighthouse. So at that stage on the page in the application, it's performing a Lighthouse audit. If I flip that to be Axe, it's going to perform an accessibility audit. Excuse me. Now, the implications of doing that are that when you run that test with that configuration, instead of a functional test, it's either going to come through as an accessibility test now or an audit test. So these are reuse of your same test, but for a different testing purpose, a different quality perspective. So this is really powerful stuff to be able to do this and to report on it in the same way. So the drill down concept is very similar. So this is our accessibility results. So we ran one accessibility check. It's recorded 6 violations. I didn't specify any particular accessibility standards, so it's assessing the application against all known standards that it supports. And our run card tells us it didn't find any criticals, but there were 2 serious, 2 moderate, 2 minor. So if I want to understand about the details of those, I just dive in. So we have a similar flavor of dashboard. I can see that my test scenario, because I ran it as an audit test, is now classed as a failure because it recorded these violations. So I click in here. Same style report, I've got a red stripe, but now I've got a different type of data. I'm not looking at screenshots now, but what I'm looking at is detail, very low level detail of these accessibility violations. And again, if I decide I want to raise these for my developers' attention, I can just raise the bug and it's going to send that through. So we have other webinars on accessibility, of course, but where this link would take you, for example, is to the DQ University page, which is going to explain to you in no uncertain terms why this is an issue from an accessibility point of view. Okay, so each one of these violations, whether it's a serious or a moderate or a minor, it's going to have a link out to that guide and a very clear explanation of why this is considered an accessibility problem. Okay, so just quickly, I'll come back and we'll look finally at the third type there. So auditing, this is a Lighthouse demo. So it's the same single line of code with a different configuration to run it as a Lighthouse test. And we get a separate run card for that. So straight away I can see that on that page where I ran the check, it got a low performance score. Accessibility was okay, but not what it should be. It's 85, it wants to be above 90. But coding best practices and SEO are ranking both pretty well. All right. But again, I can click into this and I have all of this information. Still considered a failure because the 85 was not up to or above my threshold of 90 by way of the scoring that I can set, so it's considered a failure. There's the scores, I can click in. All right, I can see the scores. What's nice here, we get a fully detailed, broken down Lighthouse audit report within Halo on a real-time basis, you know, as these results are coming in, and you get all the details. You can start to dive down, and again, you know, you can raise bugs with the developers. What we do in terms of raising bugs here is to simply pass through the listing or the label, the page, along with the URL with the scores there. Obviously, there's far too much detail to try and get into a single Jira ticket, so what we do is pass through a link back to this specific report in Test Evolve Halo, so the developer who's working on that ticket can just come right back in and see the report for themselves. That's the easiest way of getting them the detail. Okay, so there you go. Just as a reminder, we implemented that with this single line of code in an existing test that we've either recorded or refactored ourselves. We've been through all of that today, what the page object model now looks like. I've now added this one line of code. If I don't run this as an audit test, that line of code will do absolutely nothing. It can sit there perfectly happy, and then when you do configure it to run it as either a Lighthouse or an accessibility test, and you output your results to Halo, to the dashboard platform, this is the kind of data you're going to see. All right, and this let's just remind ourselves of what that real-time view looks like. Let's see how that's now doing. So it's still only the one failure, running pretty quickly. We've run 180 tests in the time that we've been talking about this. And there you go, just that one blip of red at the top of my pile. That's the only thing I really need to focus on right now. I'm 32% through this test run. My average scenario is taking 14 seconds. This is looking like a pretty good run. All right, so lots and lots more green there, more tests have been run.
if you do click on these, actually that's an example of what I wanted to show you there, if I can find that. There you go. So this was a test that finally passed, but it passed after 2 attempts. So we consider this to be flaky. What we mean by that is you probably want to, even though it's passed this time, it could easily fail the next time. You're going to want to look at that and make sure that test is as resilient as it can be. It's got the required dynamic weights to kind of work nicely with your environment, etc. All right, so that's a bit of a whistle-stop tour of Halo. Okay, so really all you do to push your data to Halo, once you start running your tests, you'll need an API key, which you will come down to the settings down here, and as an administrator you can create an API key. You put that in your config, and you give your run job a label, and when you run that for the first time, it's first going to appear in this unassigned labels page. But this is all documented on our GitHub site and on our YouTube channel. Okay, but yeah, the idea of real-time results reporting as you're testing, with the ability to diagnose as it's still running and raise bugs as it's still running, is a nice, powerful feature. So there you go. That is Axe and Lighthouse auditing and real-time reporting with Halo. Of course, you can invite as many people as you want to Halo as part of your plan, as part of your team or business plan, or even as part of your free plan. So you can have 3 users on a free plan, and that's forever available. Okay. All right, we'll leave it there. Thank you very much.
Well, that brings this evening's webinar to a close. So thank you so much for your time. I really hope that's been useful. Okay, so I think it does show that you can get up and running in a short space of time and be productive, right? Contributing to the automation effort within your agile delivery teams. So if you're interested in the Ruby equivalent, please just go and check it out on the YouTube channel, just to give you another perspective. But yeah, I think as you see from the Testal Spark framework, you'll see commonalities between both of those. So yeah, maybe one project you pick Ruby and another project you pick JavaScript, but we want to take you on that same journey. The experience should be the same for both versions of the framework. So anyway, please find us on testevolve.com, or check our GitHub pages for full documentation and a breakdown of all of the features that Testevolve offers you, not all of which of course we've covered tonight, but as I say, you can get a fully featured version of our Pro product completely free of charge for 90 days. And as I said earlier, we will always support a completely a freemium version of our product, free forever. And maybe that's all you need. That we're going to give you 300 tests per month and 3 users. But either way, if you're just looking to get up and running, get started, then why not give us a try? So thank you for your time. If you like what you've seen tonight, please give us a thumbs up. Please subscribe to the channel and keep an eye out for new content coming frequently. Okay, have a great night. See you then. Thank you.